Assalamualaikum and good morning, sir. Today we will present our mini project Self Balancing Robot. My name is Siti Aliana binti Sazli and my group member Abdul Aziz Syami and Faiz Aiman. Okay, for introduction, a self-balancing robot is two-wheel robotic system that can maintain its upright position automatically, and the system operate based on the invented pendulum principle. And last, the robot uses an ESP32 microcontroller, MPU 6050 IMU sensor, and a PID control algorithm to achieve stable balancing. For objective, first one, design and develop a two-wheel self-balancing robot. Second, implement a PID control algorithm for real-time balancing. Third, evaluate the balancing performance of the developed system. And last, provide a practical platform for robotic and embedded system learning.
Okay, system architecture and block diagram. Now I will explain the system architecture of my self-balanced robot. This block diagram show how all components work together to keep the robot balanced. First, 11.1 volt LiPo battery supply power to the entire system. Next, MPU 6050 IMU sensor continuously measure the robot angle and angular velocity and send information to the ESP32 microcontroller. Okay, the ESP32 is a main controller of the robot. It process the sensor data and apply the PID control algorithm to calculate the correction need to maintain balance. Okay, based on the PID calculation, the ESP32 send PWM signal to the Cytron MDD3A motor driver. Okay, we move to the next slide. Hardware and software component. This slide show how the hardware and software used to develop the self-balanced robot. Hardware, the first hardware component is the ESP32 developed board. Second, the MPU 6050 IMU sensor, and it contain accelerate meter and gyroscope to the measure the robot angle and angular velocity. It receives control signal from the ESP32 and control the speed and direction of the DC motor. Okay, software. For the software, I use the Arduino IDE to write, compile, and upload the program to the ESP32. The wire library is used for I2C communication between the ESP32 and the MPU 6050 sensor. Okay, next.
Okay, so myself, Aziz Shameh, I will present about this methodology. So, as we can see here, the project was developed through a systematic process consisting of hardware design, software development, and system integration, and PID tuning. And we are using performance testing to achieve stable balancing performance. And we already put our timetable here. So, our project follows several development stage. So first, we design and assemble the hardware components. And next, we develop the software and program the ESP32 by our coding. And after that, we integrate the hardware and software into one complete system. Then we also tune the PID parameters to improve the balancing and performance. So finally, we tested the robot several times and adjust the parameters until the robot could balance smoothly and reliable. So as we can see the timetable, we already put first we start literature review, second project planning, third component selection, four hardware design, number five software design, and number six, we hardware assembly. Number seven, we just use the circuit wiring and testing. Number eight, program development. We are using upload to ESP32. Number nine, system integration. And number 10, testing debugging. Number 11, PD transfer tuning. PID. And number 12, performance and evaluations. Next. And yeah, for conclusion and future improvement, Our conclusion for our robot is the project objective was successfully achieved. And the second one, the ESP32 and PID control provide stable balancing performance. And number three, the developed robot demonstrate the effectiveness of closed loop control system. And for our future improvement, we can also use autonomous navigation, obstacle avoidance, wireless monitoring, and computer vision integration. So we successfully achieved all the objectives of this project. So the ESP32 combined with the PID controller was able to maintain stable balancing and proving that closed loop control systems are effective for this type of application. And for future improvement, we plan to add, as I mentioned earlier, autonomous navigation so the robot can move independently, obstacles avoidance using additional sensor, wireless monitoring through Wi-Fi or Bluetooth, and computer vision to make the robot smarter and capable of recognizing its surrounding. Next. And thank you for all. This is our presentation about our balancing robot, and thank you so much.
Thank you, sir.
Thank you, sir. Dah.